For this lesson, you are filling in what the measure of angle A is. So we're going to start by figuring out this piece so we can use the idea that 180 degrees inside of a triangle to finish that missing piece. So right here I have a straight line, which is 180. So if I'm trying to figure out this missing piece here, I'm going to subtract 143 from 180. 10 minus 3 is 7, 7 minus 4 is 3, and 1 minus 1 is 0. So then this piece must be 37 degrees. Well, I know that the three angles in a triangle have to add up to 180, so I need to figure out this missing piece. We're going to start by combining 62 and 37 together. That gives us 99. So to fill in this missing piece, 180 minus the 99 degrees we already have will help us figure out the missing angle A. 10 minus 9 is 1. 17 minus 9 is 8. So this angle A should say 81 degrees. Again, you are going to fill in what the missing angle A is. The three angles in a triangle have to add up to 180. So start by figuring out how much is already there and subtracting to figure out how much is left. Circle the transformations you would use in a sequence to show that DEF is similar to ABC. So to start out, we're definitely going to need a dilation because these two side lengths are not the same. So we need to change the size to make them match. We might also translate to make these points line up. Then we could rotate so our triangle looks something like this around point A. And then we could also reflect over that line to make them match up. Another method that you might try is reflecting over a diagonal line and dilating. With the reflection over a diagonal line, you may not need the rotation. Follow the directions to draw two triangles, A, B, C, and D, E, F. Then decide whether they are similar. Complete part A with a partner, then complete parts B through F independently. So you're going to choose two angle measures that will be in both triangles. I am going to use a 45-degree angle and a 60-degree angle. Then it says to use a protractor to draw two distinct triangles with the angle measures from part A on an index card. Cut out the triangles. So we need a protractor for this lesson. I'm going to start by drawing a line, a straight line, for my triangle. Then I'm going to create a mark at 45. And then I'm also going to come over this direction. Oops, this should say 45. Then I'm going to move this one over here, and I'm going to use the other side to create a mark at 60 degrees here. Then I'm going to connect them and indicate that this is 60 degrees. And my line here may need to continue until it intersects. So let's sketch that line out a little further until they cross. So there is one of them. And then it says distinct, meaning they are two different triangles. If it said identical triangles, we would want them to match. So this time I'm going to draw another line. This time I'm going to put the 60 on the left-hand side. So put a mark at 60 and connect the corner to that point you just made at 60 degrees. And I'm going to put the 45-degree angle on this side. So we're using the inner 45 here. You can see that there's 40 and 50, so it should be right in the middle of 40 and 50 to give us 45. And we're going to go from the corner through that dot. So this was a 60-degree angle, and this was a 45-degree angle. I guess I should indicate that this has a different measure than this one, using one arc versus two. And then it says trace both triangles onto the space provided. Label one A, B, C, and one D, E, F. I made A match with D because those both came first, and they are both 45-degree angles. I matched B with E. Those came second, and they are both 60-degree angles. And I matched F with C because those are both the angles up at the top. It also says label the angles of each triangle with the measurements you use from part A. So you can see I have 45 and 60 labeled in both. And then it says measure the lengths of the sides and show that the lengths of the corresponding sides of the triangles are proportional. So now we're going to use our ruler tool. And we are going to measure the length of the sides. So ED appears to be about 6.7 on my paper. And AB appears to be about 5.5. Now we're going to go the 60-degree angle up towards the top. Come on, rotate. So here I have, this is about 6.2. And then over here, measuring the 60-degree angle going upwards. This one is about 4.1. Wait, check that again. Oh. This should have been 8.7, not 6.7. 8.7. Okay, and then check and make sure I have that measurement correct. Yeah, about 5.5. Okay, now we're looking at that 45-degree angle side. This is about 7.6. And then looking at this 45-degree angle side. That is about 4.9. 9. Okay, so again, these are all rough measurements. They're not perfect, and these sketches are angle measurements, might not be exact. So we're looking for something to be close. So 6.2 divided by 4.1 comes out to approximately 1.5. 8.7 divided by 5.5 is about 1.6. And 7.6 divided by 4.9 is also around 1.6. So it says, show that they are proportional. Now the discrepancy between these is that we're measuring in tenths instead of hundredths, and also that we are trying to visually just identify what those measurements are. So there's some human error, but they're pretty close. And so we can say that since the scale factor is about the same for all three sets of sides, that these sides are proportional. Lay the triangle cutouts on top of the traced triangles in the book. Is there a sequence of motions that maps one triangle ABC onto a congruent triangle DEF? If so, describe the rigid motions. So based on my triangles, just using rigid motions, there isn't a sequence that would map this one onto the other because we would need to use a dilation. So here in part D, we would say no, there is not a sequence of rigid motions that maps ABC onto DEF. Part E, after applying a sequence of rigid motions, can a dilation that maps ABC onto DEF be precisely described? If so, describe the dilation. So using the dilation also, can we move from ABC onto DEF? So we can start by dilating ABC by a scale factor of 1.6, like we saw when we found the ratio or the proportion. And we're going to do that from point A. And then we are going to translate from point A, a vector, to point D. So we're scooting it over. So we've increased its size, so they're the same size, using that dilation. And then we're going to scoot it over using that vector. And then we are going to reflect over line L. So is ABC similar to DEF? Yes. If we were to reflect, it would flip over and line up perfectly. Yes, it uses rigid motions and dilations to map ABC to DEF. Points A, K, and T are collinear, meaning they fall on the same line. A, K, and T. And points A, S, and C are collinear, falling on that line. Are ASK and ACT similar? Those two triangles. Completes part A through D to determine the answer. What two pairs of angles are congruent in the diagram? Well, angle AKS, remember K is in the center, so the K is the center letter, is congruent, we use that squiggle over the equal sign, to ATC. And we also know, we know those two are the same because they have those two arcs drawn in the corner. We also know angle A is equal to itself. So angle KAS is congruent to angle TAC. Based on the information, what can we conclude about KS and TC? Based on this information, we can conclude that that segment KS is parallel to the segment TC. KS is parallel to TC. And it says explain your conclusion. And we know that these are parallel because this angle K and this angle T are considered corresponding angles. These are parallel, so this one is a transversal, and we have corresponding angles here. Describe the sequence that maps ASK onto ACT. It would be a dilation, from A and the way that we can describe this scale factor is whatever this distance from C to T is, this distance here, divided by this distance from S to K. So what can we conclude? Well, if you can make a dilation, align them up, then we can conclude that ASK is similar to ACT. If it's a sequence of dilations and rigid motions, they must be similar to one another. For problems 4 through 9, determine whether the triangles are similar by the angle-angle criterion. Explain your reasoning. So angle-angle criterion is something we haven't heard about recently, but it is something we discussed earlier in 7th grade, and I believe earlier in 8th grade as well. So angle-angle criterion says if two of the angles are the same, then this third one has to be equivalent to the third one here. So I have an 80-degree angle and an 80-degree angle, and a 25 and a 25. So yes, these are similar by AA criterion. So angle K is congruent to angle D, and angle E is congruent to angle U. Therefore, okay, in math, we can use these 3 dots as a quick shorthand way of writing the word therefore. Triangle, KEY, is similar, oh, that would be the congruent symbol, similar to triangle. A matches up with D, E matches up with U, and Y matches up with B. In this one, I have U and A are the same. M and T are the same. Therefore, triangle TAB is similar to, well, T matches up with M, and A matches up with U, B matches up with H. in these, I only have one angle that matches, but I have to figure out what this other angle is, because if it's 17, then I know these are the same triangle, or these are similar triangles. So 180 minus 129, 10 minus 9 is 1, 7 minus 2 is 5, and then we're going to subtract 34 from 51. 11 minus 4 is 7. 4 minus 3 is 1. So that means this angle has to be 17. So angle B is congruent to angle H. And angle A is congruent to angle U. Therefore, triangle BAT is similar to B matches up with H, A matches up with U, and M must match up with T. Here I have a 28 and an 80. 80 plus 28 is 108. 108 removed from 180 will tell me how much is left for this angle A. Oops. 10 minus 8 is 2. 7 minus 0 is 7. So here I have a 72-degree angle, an 80, and a 28. It doesn't match up with any of these. So those are not similar. There aren't any pairs of congruent angles. Here I have a 90-degree angle and a 90-degree angle. 90 plus 59 is 149. 180 minus 149. 10 minus 9 is 1. 7 minus 4 is 3, is 31. So you can see angle A is congruent to angle D, and angle C is congruent to angle F. Therefore, ACB is similar to A lined up with D, C matched up with F, and E matches up with B. Here I have a 103 and a 31. If I add those together, that gives me 134. If I subtract 134 from 180, that tells me how much is left for this angle. 10 minus 4 is 6. 7 minus 3 is 4. So this angle is 46. I only have one angle that matches. The other ones do not match up. So these are not similar. They only had one set of congruent angles. For angle criterion, we need two sets. One set, two sets. One set is not enough. Make sure your workbook is filled in for this lesson, and then check back for lesson 13 later on.